and you hit second distribution and hit normal CDF. Remember, CDF means that it's cumulative. Okay, and you're going to put in your low boundary, so I don't know, negative 10,000, and then your high boundary, which is negative 3.54, and then you need 0 and 1, which is the mean and standard deviation of a normal distribution. Oops. What did I do wrong? Did I go backwards? High, low, 0, 1. I think that's right. Low, high. I don't think they make you go high, low. Saying I'm getting a syntax error, so obviously I'm doing something wrong. Of course, I did it right when I was on my own. Let me look it up quick to make sure that I give you the right information. Okay, let's see. It needs to be... Oh, did I put in a... That's stupid. I put in a subtraction sign instead of a negative sign. Man, that's something that I like rail on my students about. Whoops. All right, well, that's easy to fix. So it says that it's 2.001 e to the negative 4, which means that you move that decimal place 4 times. So the correct answer, instead of you saying approximately 0, you should say 0.0002. So that is the chances that the inspector will conclude that it contains fewer. Remember, fewer is to that left-tailed test. So basically, we've got like a left-tailed test going on right here, and this is negative 3.54. We're looking for that area over here, which is 0.0002. All right, now suppose the roll actually contains 49 pennies. Using the inspector's rule, is the inspector likely to conclude that the selected roll contains fewer than 50 pennies? Justify your answer. Okay, so we need a new mean and standard deviation for this. So we're going to do that 2.5 times 49. And then your sigma is going to be, what was that point? Was it 0.4? Yeah. 0.04 squared times 49 pennies, and then the square root of that. So those turn out to be 122.5 and 0.28. And then we're going to do the x minus mu over sigma thing again, using the same x. So 124 minus 122.5 divided by was it just 0.28? Yeah, 0.28. And then if you do that, you end up with a z-score of 5.36, which is pretty much off the charts. So the question is the inspector likely to conclude that the selected roll contains fewer than 50 pennies? Remember that this time we're talking about 49 pennies. So it's kind of like over here, this 5.36. What are the chances that essentially it would be larger than 124? And even though there were 49 pennies in it. And this is so off the charts. And if you did like a normal distribution on your calculator, you would see that this is essentially 0. So the answer to their fewer question is the inspector likely? Yes, he is. Almost 100% chance he'd get it right. And there's your proof with your z-score and all of that stuff. Okay, and then we're going to go down to E for the last problem. Says, based on your answers to C and D, comment on whether the inspector's rule will be effective. Yeah, it will be. It'll be very effective. And it says that we need to comment on C and D, so I'm going to do that. So part C tells us that there is a 0.0002 chance that the inspector will mistakenly say a machine is malfunctioning. Sorry, not that. Mistakenly say that, we should be more specific there, that a roll contains less than 50 pennies when it has 50 pennies, actually. And then part D tells us that the chances of 49 penny pack will slip past inspection is extremely unlikely. So essentially, Part C says that the inspector has a 0.0002 chance of mistakenly saying that a pack has 49 when it actually has 50. And Part D tells us that the chances of a 49 pack slipping by inspection because it's heavy enough is way unlikely, like 0% unlikely. So, all right. This is very much what that longer question will look like on the AP exam. At least the length of it, not necessarily the content. We can't guess on exactly what they're doing there. So make sure you're going over stuff that you don't know today. Maybe like, do you remember how to do binomial distributions and geometric distributions and stuff like that? If there's anything that you are uncertain about, make sure that you post it in the discussion section or just email me directly or text me and let me know what you need help on, because today's the day to ask questions. Tomorrow's the test. So good luck, guys. I wish you the best. I know you're going to do absolutely fantastic, and I miss you. Bye.